Hello and welcome back to CodeMechanic. Today, we are tackling a common but sometimes tricky fault CodeMechanic on your heavy equipment. SPN 4334 FMI 5. If this code has popped up on your dash, you're in the right place. We're going to break down what it means, why it happens, and most importantly, how to fix it so you can get your machine back to work with minimal downtime. So, what exactly is SPN 4334 FMI 5? Let's decode it. This specific code points to an open circuit in the heater of your NOx sensor. NOx sensors are crucial components in modern diesel engines. They measure the nitrogen oxides in the exhaust gas to make sure your engine's after-treatment system is working correctly and meeting emission standards. Think of them as the quality control inspectors of your exhaust. Now, for a NOx sensor to work accurately, it needs to be very hot, usually several hundred degrees. That's where the internal heater comes in. It quickly brings the sensor up to its optimal operating temperature, especially during a cold start. FMI 5, which stands for current below normal or open circuit, tells us that the engine's control module, or ECM, tried to send power to this heater, but it detected a break in the electrical circuit. Essentially, the electricity isn't making it to the heater, or the heater itself is broken. So what causes this open circuit? There are a few usual suspects. The most common cause is simply a failed NOx sensor. The heater element inside the sensor can burn out over time, just like a light bulb. It's a wear and tear item, and after thousands of hours of operation, it can heat up. This is often the case if your machine has high hours. Another frequent culprit is the wiring. The wiring harness leading to the NOx sensor lives in a harsh environment. It's exposed to extreme heat, constant vibration, and potential contamination from dirt, oil, and moisture. A wire could have rubbed through its insulation and broken, or a connector pin might have become corroded or pushed out of place. It's also possible for the connector itself to be damaged. Always give the harness a good visual inspection from the sensor all the way back to the main harness connection. So, how do you diagnose this properly? First, always start with a visual inspection. Look closely at the NOx sensor itself for any signs of physical damage. Then, trace the wiring harness. Look for any chafed, melted, or broken wires. Pay special attention to the connector. Is it securely plugged in? Are the pins clean and straight? Sometimes, just unplugging it, cleaning the contacts with a good electrical cleaner, and plugging it back in can solve the problem. If the visual inspection doesn't reveal anything obvious, it's time to break out the mold. You'll want to check for continuity and resistance. Disconnect the sensor and the ECM connector. First, test the heater's circuit wiring between the ECM connector and the sensor connector. You should have very low resistance, close to 0 ohms, indicating a good wire. If you get an OL or infinite resistance reading, you have a broken wire that needs to be repaired or replaced. Next, you can test the heater element within the NOx sensor itself. You'll need the specific resistance value from your manufacturer's service manual, as this can vary. Measure the resistance across the heater pins on the sensor. If the reading is infinite or way outside the specified range, the sensor has failed internally and needs to be replaced. If the wiring checks out and the sensor resistance is within spec, the problem could be more complex, potentially involving the ECM itself, but that's much less common. In most cases, following these steps will lead you straight to the problem. If it's a bad sensor, replacing it is the only option. Remember to use a quality replacement part. After replacing the sensor or repairing the wiring, clear the fault codes and run the machine. The code should now be gone. It's also a good idea to perform a forced regeneration of the DPF system if possible, to ensure the entire after-treatment system recalibrates correctly with the new sensor. And that SA wrap on SPN 4334 FMI 5. It usually boils down to a failed sensor or a wiring issue. With a systematic approach and a multimeter, you can diagnose it accurately and avoid just throwing parts at the problem. Thanks for watching. If you found this video helpful, give it a thumbs up and hit that subscribe button for more heavy equipment diagnostic guides. Drop a comment below if you have any questions or if there is another code you'd like us to cover. Stay safe and keep those engines running.